Hey, what's up everybody? I'd like to welcome you to another audio programmer tutorial. And in this video, we're going to learn how to connect your plugin parameters to a simple user interface using JUCE's AudioProcessorValueTreeState, or what some people call APVTS for short. This is an essential step if you want your knobs, sliders, and other UI elements to control your plugin's parameters and give users the ability to create automation for those parameters inside your DAW. This will also make sure your plugin can be saved and loaded correctly when we cover this subject later in this series. If you're just getting started, this is the perfect tutorial for you. First, we'll look at how to create and manage plugin parameters using the APVTS. After that, we'll link those UI elements directly to those parameters. And finally, we'll test everything to make sure that your plugin is working correctly as designed. So here's what we're going to be creating today. So here we have a frequency slider that is now connected to our frequency parameter in our audio processor. We also have a button that can play or bypass the audio as well. Now, one thing that you'll notice is as I was moving the slider up and down, you're hearing some crackling and what they call artifacting. And this is going to be something that we're going to fix in our next tutorial, which is going to be on smoothing those values so we don't hear those abrupt changes and those crackles and breaking in audio. But don't worry about that for now. There's so much to pack into this tutorial about just getting all of these parameters hooked up to the user interface that I didn't want to pack too much information into one video. There are some new C++ concepts that we'll be using today that will be helpful for you to familiarize yourself with beforehand. These include the basics of initializer lists, atomics, pointers, and unique pointers. I'll put some links to the video tutorials on these below, but if you get confused, ChatGPT or another LLM will be able to help you through the rough spots. And if you're curious on how to build your own plugins, be sure to check out our community, books, and services. You can find all these on our website, theaudioprogrammer.com. I'll also put a link to the code in the video description below. And without further delay, let's get started. Let's start things off with a diagram that should give you an overview of the Audio Processor Value Tree State, or APVTS, and how it fits into what we're doing with audio plugins. So as you know from previous tutorials, we have two sides to our plugin. We have the editor, or what some people call the user interface, which is what the user sees, where you have the sliders and buttons and so on. Then on the other side, we have the audio processor, and that's where our parameters live, such as frequency and amplitude. And we want to make a connection between those sliders and those controls and have those control the parameters on the audio processor side. And that's where the APVTS comes in. So the APVTS is that bridge between the UI and the processor, and it's responsible for what we call state. By state, what we mean is if you were to take a plugin, or for that matter, any app, and you were to freeze frame it for a moment, just take a snapshot of it, then you would have some different parameters. Let's say it was a synthesizer and that we had something like an LFO that was turned, the rate was turned to a certain value, the filter cut off, the type of oscillator that your synthesizer may have, and so on. And you can take a snapshot of that, and then you can save it if you wanted to and load it, and that becomes what we call a preset, right? So the APVTS is responsible for all of that. It's responsible for managing what the state of the application is, so that snapshot, and for keeping everything in sync between the user interface and the changes that the user may be making and the audio processor and what's happening on that side. So the user is making a change, and then what's happening is that that change is being relayed to a corresponding value or parameter that's on the audio processor. And conversely, what we won't really get into today, but something else that can happen is that something may happen in the audio processor. Some value may change, and that may need to be reflected in the user interface. And so this data exchange can happen both ways, but the important thing to know is that the APVTS is what manages all of this transfer of data that's going from the editor to the processor, or from the processor back to the editor. jumping over to the code now, here we are in our sine wave class in sinewave.h. And what I've done in one of the previous tutorials when I created this class was I created two ways that we can change this sine wave. So we can change the amplitude of this using set amplitude, so change how loud or how soft the sine wave is, or we can change the frequency of the sine wave using set frequency. Let's start off with frequency. So the first thing that we want to do is create what's called a parameter layout. A parameter layout is simply a list of all the parameters that we're going to have in this plugin. We can see here from the description that it says a class to contain a set of ranged audio parameters and so on and so forth. But I think this is a little bit misleading. I think a more accurate way of saying this is a class to contain a set of unique pointers of ranged audio parameters. Because if you look down here to the template constructor, we can see here that the parameter layout is containing unique pointers of each one of these ranged audio parameters. So I'm going to show you how to do that. If you're feeling a little bit overwhelmed, don't worry. I'm going to break this down step by step. All right, here we are in our plugin processor.h, and I'm going to create a function that's going to return a parameter layout. I've decided to call the function create parameters. Now let's implement this in the CPP file. Great, so now we've created our function called create parameters. Now some of you may be asking why I decided to do this as a function rather than creating a parameter layout object and simply giving it the list. And the reason is because I want to control when this layout is actually generated, and that will come into play a little bit later. So now we need to create some pointers of some ranged audio parameters. Here we have the ranged audio parameter class, and this class is used to represent the different types of parameters that we can use for our APVTS. So here we have an audio parameter bool, which could be used for a button on or off. We have audio parameter choice, so an example of that could be something like filter cutoff if you had high pass, low pass, band pass, so more than two choices. Then you have audio parameter float, which is floating point number, and audio parameter int, which could be used for something like number of voices, right? So frequency is going to be represented as a float. So for this reason, we're going to use this audio parameter float. Now we need to figure out how to create an audio parameter float. So let's click in here. And we can go down here and we can see that there are three different ways that we can create an audio parameter float. And for this example, we're just going to use this most simple one here. And this is going to take a parameter ID. So parameter ID is simply a string that we use to create what we want to call the parameter. And that parameter is what I would call the internal parameter name that would be used within the plugin. The second part is the parameter name that the user is going to see. So there's an internal parameter ID, and then there's an external parameter name that the user will see. So that's what the second parameter is. Then we can give it a minimum value, a maximum value, and a default value. So for something like frequency, normally that's going to go between 20 and 20,000 for our hertz. So the minimum value will be 20. Maximum value will be 20,000, and the default value could be something like 220. So let's go ahead and create an audio parameter float now. All right, here we are back in the code. Let's go ahead and create our JUCE audio parameter float. I will call this frequency. Now, going back to our documentation, the first argument is an object type called a parameter ID. So if we open this up, we see that it has this combination of what's called a parameter ID, which is just a string, and it has an optional argument for what's called a version hint, which we won't get into today. So this is how we're going to initialize this. We will call this freq HZ. The second argument is what we want the user to see the parameter being called. I will just call this frequency with a capital F. The third argument is the minimum value. We will make this 20.0 as a floating point value. Then we have the maximum value, which will be 20,000. And the default value, which we'll set to an arbitrary number, something like 220. And now we have created our first audio parameter float. Now what we need to do is wrap this in a unique pointer, because as we can see from our documentation, this parameter layout is going to be unique pointers of items, not just the items themselves. So let's go ahead and create a unique pointer. And what we're going to do here is we're going to create and allocate the memory for this all in one command using std make unique. Here we need the type of object that this unique pointer is going to be, which is going to be a JUCE AudioParameterFloat. And in here, we're going to move our arguments that we created earlier. And now I can erase this original audio parameter float that we created before. Now what we want to do is we want to return this list. So the way that we do this is with the command return. And we just put some brackets around this. And we take away the semicolon. Don't forget to put the semicolon after the return brackets. And now we have just created our parameter layout that has one parameter, which is our frequency. Next, let's create our audio processor value tree state object. And what we can do here is look at our documentation, and we can see that it has quite a few different little tools, classes, and structs that we can use. So one of those we've used already, which is the parameter layout. Scrolling down a little bit further, we can see that we have two different types of ways we can construct this object. We can see that the second way has been deprecated, and so that means that we really only have one way that we can do this. And the arguments this is going to take is the audio processor, so that's going to be our audio processor class that we're already in. It takes a undo manager, and this is optional. This is a pointer, and we're just going to set this to null pointer since we're not going to be using an undo manager in this tutorial. And then it has what's called an identifier, which is the value tree type. This is just a name if we needed to refer or look for this audio processor value tree state object somewhere in code. Normally I just call this something like parameters. And then finally, it needs our parameter layout that we've created earlier. So let's go ahead and create this audio processor value tree state object. First, let's create our audio processor value tree state object. I will call this state. Next, I need to initialize the state object. And the best way to do this is using an initializer list. So this is going all the way back up to our constructor. And what we could do is use our initializer list. If you're not familiar with initializer lists, I have a link to a tutorial below that'll show you what those are. And the way that we do this is we are just going to initialize this state in line like this. Now let's go back to our documentation and see what arguments that we need. So the first one is the processor to connect to. So it takes an audio processor object. As I was saying before, the class that we're actually in is the audio processor class that we're needing to connect to. And if you're familiar with other languages, you may be familiar with the concept of this. This is a keyword that we can use to refer to the class that we're actually in. One of the big differences between the this object in C++ versus other languages is that in C++ it's actually a pointer, and we need to dereference that using the asterisk before it. So it will look like this. The second argument is going to be the undo manager, which we're not going to use. So because it's a pointer, we could just set it to null pointer. The third argument is that identifier, which is just a string if we wanted to refer to the state object by name at some later point. So I'll just call this parameters. The last argument is the parameter layout object, and that will be handled via the function that we created earlier called create parameters. So create parameters will run, and that will return our parameter list, which currently contains one parameter, and that will give us our parameter layout. So up here we can just call the function create parameters. And now we are good to go. So now we have created our APVTS object, which is called state. That has our parameter layout, which is our list of parameters. Here we only have one parameter, which is our frequency, which is called freq_hz. And now we need to find a way that we can connect this parameter to the slider that we've created in our user interface. Going back to the documentation, the audio processor value tree state has a handy class called a SliderAttachment. So this is an object that will create the connection between the slider and a parameter in the audio processor value tree state. So this is exactly what we need. To create a slider attachment, we need to give it an audio processor value tree state object. We need to give it a string, which is the parameter ID. So the parameter ID, just to review, is this first argument that we made when we created this parameter, freq_hz. And finally, we just need to give it the slider that we're connecting the parameter to, which is going to be our frequency slider. So let's go ahead and create one of these objects. So it's JUCE AudioProcessorValueTreeState SliderAttachment. I will call this freq_slider_attachment. Once again, I'm going to use an initializer list to initialize the attachment. So it's freq_slider_attachment. Going back to our documentation, the first thing that it needs is our audio processor value tree state. Now, we have a problem, which is that if we go back into our plugin processor.header, we see that this object is in private, so it can't be used outside of this class. So there are two ways that we can handle this. One is that we can take this state object and we can make it public. The way that I'd like to do this is using a getter, which will get us a reference to this state object. I just find that if you're giving it to somebody else to read the code, that it's a little bit cleaner. But people have differing opinions about this. In principle, it's not really doing anything different than just giving it direct access to the state object at the end of the day. But I like to do this just for cleanliness. So this is going to be JUCE AudioProcessorValueTreeState. Make sure it's a reference using the ampersand. So that makes sure that it returns this actual state object rather than creating a copy of the state object. And then I will just call this getState. And then this will return the state. So that returns our state object. Now, if we go back over to our plugin editor, we see that the boilerplate code has this reference to our audio processor, right? So this is just a way that we can access the plugin processor. So now going back to the way that we need to get our state object, it would be processor ref get state. Okay, see how I did that there? So that may be a little bit to get your mind around if you're just starting off, but you'll wrap your head around it eventually. Now going to the second argument, we need the parameter ID. Now it's very important that you get this exactly right. Okay, it's this freq_hz. if this is wrong in any way, if anything's capitalized, it's supposed to be lowercase and so on, this will not work properly. And unfortunately, it won't really give you a good, sometimes it'll crash and it won't really tell you anything. And other times it doesn't crash. It's just the connection doesn't work. And you're left wondering what's happening. But it's very important that that parameter ID actually exists in the parameter layout. Then the last thing that we need is the slider that we're trying to connect it to, which is this frequency slider. So we will just input frequency slider here. And now we have our parameter attached to our slider. The next question becomes, well, how do we get this value and how do we use this back in our plugin processor? So what we're going to do is we're going to have a slider and we're going to move it, but we don't have anywhere where we're actually using it just yet. And so I'm going to show you now how to actually get that value and use it to control the frequency of the sine wave itself. Before we do that, I wanted to test out our plugin, make sure that it's actually all building correctly. So let's hit run here. So we can see that there's a little problem, which is that the slider is actually supposed to take the values from the parameter that we've set here. So the range of this is supposed to be 20 to 20,000. And we can see that the range that we actually had for the slider was between 0 and 20. And that's because we have a little bit of a mismatch here that's happened because the parameter is trying to set what the slider values are, but we also have these commands set range and set value where we're trying to set what those values are directly in our user interface. So now we just want to get rid of these. Okay, so set range and set value, we get rid of those because now what's going to happen is that the slider is going to pull the values of this that the slider is supposed to be from the parameter that it's connected to. So let's go ahead and build this again and make sure that we're actually getting the proper slider range. All right, so now we're getting the right range for the slider and we can move on to the next step. To get the value from one of our parameters, we need to go back to our AudioProcessorValueTreeState. If you scroll down a little bit, you're going to see a function that's called getRawParameterValue, and then it takes an argument which is a string to the parameter ID. That's the way that we identify what parameter that we're trying to take a look at. And that's going to return a stood atomic float pointer. Now, if you're just getting started, that may look like a bit to unwind, but I'm going to show you how to get that value back, so don't worry. I didn't want to get too deep into the weeds of C++, but thought that it might be helpful to talk a little bit about stood atomic. So as you know, there is this parameter value called frequency, and that's being used by the audio processor. So what we're going to do is we're going to want to read what that value is, and then that value is going to be changed by a separate part of the app that is the slider. So the user is going to be moving the slider, updating the frequency. And so what we don't want is a situation where you're trying to read what the value of the frequency is at the same time that the slider is trying to make a change to what the value is. And so stood atomic is a way that we can wrap a little bit of safety around that to ensure that it's only going to be able to be read or written to at one particular moment in time. So just want to go into the basics of that. And like I said, I have some tutorials that go a little bit deeper into that, and you can check those out on the links below. So once you remove that stood atomic part, then you're just left with a float pointer, and that becomes easy to dereference if you know what how to work with pointers and the basics around those. So let's go ahead and jump into the code, and I'll show you how to get this frequency value. All right, here we are back in our plugin processor and inside our process block, and we'll just do it here for now. What I'll do is I will first create a local variable. I will make this a float. I'll call this freak, and I will make that equal to our APVTS, and then we're going to use that method that we were just talking about called getRawParameterValue. And inside here, we need to put the string of the parameter ID that we're looking for, which is this freak HZ. Copy that, pop that in here. Now for the atomic part to actually get the value of this, we need one more thing, which is this load command. And now that's truly going to give us what is going to give us a float as a return there. So now what we could do is we could just call sine wave dot set frequency, and we can just pop in freak, and we should be able to get some changes from our slider now. Let's go ahead and test this out. And there we have it. It's actually working. As I was saying before, you're going to get some artifacting because those changes are sudden. And I will show you in our next tutorial how to actually smooth out those changes. But I wanted to keep this focused around the APVTS object and how to set up these parameters. So what we're going to do now is we're going to do the same process. We're going to do it a little bit quicker this time just to make sure that you got the hang of things. But this time we're going to do it for our play bypass button. So let's go ahead and jump into that. All right, we're creating another parameter. This time it's going to be a play/bypass button that's going to play the audio or bypass the audio depending on what the button state is. So for this, since we only have two states, true and false, we're going to use the audio parameter bool. And if we scroll down here to the documentation, we see here that we have two different types of constructors that we can use. One that takes a parameter ID, parameter name, so same thing as last time, and a default value, and optional argument for attributes, which I don't even know what that is. So just this parameter ID, parameter name, and a default value. So let's go ahead and set that up here in our parameter layout. So when you're making a list like this and you have more than one item, make sure that you put a comma in there before the next item. So now we're going to do the same sort of thing. Stood make unique. This time it's going to be a JUCE audio parameter bool. And then in here, first argument is a JUCE parameter ID. Now we'll just call this play with a lowercase p. Try to keep the convention straight here. That's quite important. Then, sorry, I'll do this all on the same line. And then the second one is the name of the parameter that the user is going to see. So I will do play with a capital P. Then we just need a default value, which I'm going to say true. So we're going to make this true if we want it to play, and false if we want it to bypass the audio. Okay, so it can be very easy to get these confused between should bypass be true or false, or should play be true or false. So it's just all up to the person writing the code. So there we go. We have our audio parameter bool now. So now we're going to go back over to our plugin editor. Let's go back to our documentation here. And this time we want to go for the audio processor ValueTreeState. And this time we're doing a button. So we're doing a button attachment. So same type of concept. So it just takes the audio processor ValueTreeState, the parameter ID, and the button that we're attaching it to. So we will just create that here in our plugin editor.header. So JUCE, audio processor ValueTreeState, button attachment, I will call this play button attachment. Then we will go over to the editor, to this initializer list, and I will just put this on a new line. And I will call this play button attachment. And now we just need to give it the arguments. Okay, so we could just look here for what we did before, right? So we got processor reference, which is a reference to our processor, where we can use that to get our APVTS object. Then we need the name of the parameter. So the name of the parameter here is play. And we are attaching this to the play button. Now let's go over to our plugin processor, up to our process block. And now what we'll do is create a, I'll create it as a float. The reason why I'm going to do that is because if you go back to get raw parameter value, we can see that it's still going to return a stood atomic float pointer. So this does not change no matter what, whether you're using a audio parameter bool or choice or a different parameter type. It's always going to give you a stood atomic float pointer. The only thing is, as some of you probably guessed, is that since it's a bool, it's going to give you either a 0.0 or a 1.0. Okay, so let's think about the logic here. So we're going to call this should be playing, and that is equal to state, get raw parameter value, and the parameter that we're referring to, this needs to be a string, is called play. And once again, to get the true value of this, we can call this load. Now, what I'm going to do is I'm going to try something here. I don't know if this is going to work altogether or not, which is that I'm going to try to cast this to a bool in line like this. So I could do static cast bool. So this is a way that I could just turn all of this into a bool rather than having to take it as a float. And as you can see, that worked, right? So that should be fine. Now we just need to use it to set the amplitude. So then I can say sine wave, set amplitude, and then we can do an inline if here. So it should be playing. If it should be playing, then we want the volume to be 0.4, else 0.0 because it should be muted. Now let's go ahead and build that and see what happens. There we go. We got play and bypass now. And as I mentioned before, you get some artifacting there, a little bit of clicking, and that's something that we'll go ahead and we will fix in our next tutorial. So all of this is now working and everything is working fine. I'm just going to take a few moments just to show you a little something that's more for intermediate developers on a way that you can optimize this, because one of the things that you have here is that this get raw parameter value is actually quite heavy, and it's something that we don't want to be calling every process block. So what we're going to do is we're going to move these out of here. Okay, don't panic. And I'm going to move these over to prepare to play. Okay, I'm going to get rid of this load part because I just want to get the parameter value here. And now what I'm going to do is this is going to return a stood atomic float pointer. So what I'm going to do is I'm going to replace these and I'm going to create some class members that are going to be stood atomic pointers. So let's go ahead and do that now. So we got stood atomic float pointer, and I will call this frequency, and then I will do the same thing for the other value. And I will call this play param. I'll call this frequency param as well, just to make this all the same. And now I'm going to go back over to the processor here. And now I'm just going to say frequency param is equal to this, and play param is equal to this. And I'm going to get rid of this static cast bool. I'll just cut that because I'm going to come back for that a little bit later. Okay, so now I'm going to use frequency param and play param over in the process block. Now I know what you may be saying. Why are you doing this? Because both of these return stood atomic float pointers. But as I was saying before, this get raw parameter value is actually much heavier than just using an atomic within the call, within your audio callback. So that's the reason why I'm doing this in prepare to play, so that it's just happening once, and then down here we can do a similar type of process that will be where we create a float. And I will just call this freak again. And now it's going to be equal to frequency param load. And I'm going to do the same thing that I did before with the Boolean. Should be playing. Make that equal to the play param load. Okay. And now we're going to do what I was talking about before, where we're going to do the casting play param to a Boolean. Okay, so static cast bool, and just wrap play param load in that Boolean. And now essentially you're going to get the same thing, but as I was saying before, this function called get raw parameter value is quite heavy. So that's the reason why we're just doing it in prepare to play, which is just going to be called once when your plugin is initialized. So let's go ahead and test it out, make sure we're getting the same result. So there you have it. Everything is working just fine. One other thing here I can see is that these can actually be const. So, because they don't need to be changed. So that should be getting rid of that little warning there. So now we are truly good to go. So like I said, that's not something that's just required, but it's something that is a good optimization and a good habit to form there. All right, thank you so much for joining me on that journey today. I know that it's a little bit deeper in C++ land, and for many of us, including myself, it took me quite a while to wrap my head around all the concepts that are contained in this tutorial. But please stick with it, and I think that as you stick with it, you're going to find it to be really rewarding, and that you're going to have a good time once you get off the ground. If you like this tutorial, be sure to give it a like and subscribe. And until next time, I'll see ya. Happy coding, and see you soon.